Hi, hello everybody. Welcome back once again to our channel VAAGAI Academy of Mathematics, and this is a playlist where you can find video lessons for CBSE Class 11 Applied Mathematics. So after 4 chapters in time and work, now we are into chapter 5. This is going to be the last chapter of this time and work, and here we are about to see a topic which is called pipes and cisterns. So this is going to be very similar to our previous chapters. So there in our previous chapters we have a group of people working, or we have some individual people working like A, B, C. A can finish a work in these many days, B can finish the same work in these many days. In this way we had the questions, but instead of people, here we are going to have pipes. That's going to be the only difference. Okay. So we will be having certain pipes which are going to be attached with a tank, and if you switch on a pipe, what happens is, if you turn on a pipe or a switch on a pipe, what happens is that pipe will start to fill this tank. And how much time this pipe will take to fill this tank, that's what matters. So there a person is going to do a work for which he or she will take some time. The same way here a pipe is going to fill a tank for which it is going to take some time. That's the only difference. Okay, so here these pipes you can very well treat like how we had people there. That's it. So there we may have 2 or 3 people, A, B, C. Instead of that we will be having pipes here, A, pipe B, like that. That's it. And the other important thing that you are going to learn here is it is about something called negative work. This is going to be very important thing here, negative work. So you may ask, what is this negative work? So this negative work is something like doing a work in an opposite manner. So basically, what is a positive work? A positive work is something like the work goes in a constructive manner. That's what we call it to be a positive work, right? So imagine a person is going to do a work, or you can think like a person is going to build a room or a block, something like this. We'll imagine that way. The way of constructing is going to be a positive work, and imagine there is another person involving there. He is going to come there and he is going to destruct that building. So this is a kind of negative work, right? So one person will be constructing it, the other one will destruct it. The destruction part is what we call it as negative work. And this negative works concept will be majorly, we can see this in a very broad way in this kind of pipes and cistern problems. So that is what here we are going to discuss using a very good problem. We are going to see only one problem here, and I feel that one problem is enough for you to understand how about this pipes and cisterns problem, and also how this negative work is going to take a role here. Okay, so for which let us directly jump into the question, what question we have, then we'll get into the solving part. Okay, yes, our question here, pipes A and B can individually fill a tank in 12 hours and 30 hours respectively. So initially there are 2 pipes A and B. So if you see that pipe A can fill a tank in 12 hours. So we have to match it appropriately. Pipe A can fill in 12 hours and pipe B in 30 hours respectively they gave. So A can fill in 12 hours and B can fill the tank in 30 hours. Okay, done. Next is pipe C. So that means there's a third pipe coming in. Pipe C can empty. So note the word, very important. Pipe C can empty the same tank in 20 hours. So what does it mean? So when the tank is completely full, if you switch on pipe C, what happens? Pipe C will be letting all the water out. That's a task done by pipe C. So this is what I referred as negative work. See, here pipes A and B are doing a positive work. They are filling the tank. So that means they are going to be positive work. But whereas pipe C is going to do a negative work here. So pipe C can empty the tank in 20 hours. That is, when the tank is full, if you on this pipe C, what happens? It will drain all the water. It will empty the tank in 20 hours. This is what pipe C is doing. Okay, fine. Continue the question. When the tank is empty, so you are making the tank empty And if all the 3 pipes are opened, then how long it will take for the tank to fill completely? So what you are doing is you are leaving the tank empty, and simultaneously at a time you are going to open all the 3 pipes, pipe A, B and C. Now question is, if all 3 are in function, if all 3 are in action, then how long it will take for the tank to fill? This is the question. Okay, yes, I hope the question is very clear to you. Now let's get into the solving part. Okay, fine. Start from pipe A. Pipe A in 1 hour. So as usual, let's try to work this problem through fraction method. So pipe A can fill the tank in 12 hours. That's what is given. So that means in 1 hour, how much part of the tank will be filled by pipe A? That we have to think, right? So in 1 hour, what do you mean? So how we usually do in fraction method? We will always take the reciprocal, is it or not? So in 12 hours, the pipe A will completely fill the tank. So in 1 hour, it will be filling 1/12, is it or not? So I am putting 1/12 here. Okay, fine. Pipe B in 1 hour. So pipe B can fully fill in 30 hours. In that case, pipe B can fill in 1 hour how much? Pipe B can fill 1/30 of the tank. This is also over. Now coming to this last pipe, I mean pipe C. Pipe C in 1 hour. That's what we have to be very careful. See here, pipe C can empty the tank, right? So here pipe C's task is going to be not letting the water inside. Pipe C is going to do what? Pipe C is going to drain the water outside. Whatever is filled there inside the tank, pipe C is going to throw out the water. That's what pipe C is doing here. Is it or not? In that case, pipe C in 1 hour will do what? It will take, it takes 20 hours to drain all the water. So that means in 1 hour, what will it do? In 1 hour, pipe C will be taking away 1/20 of the water outside. In that case, what I have to do is, I should put a minus 1/20 here. I hope you are able to understand this. Since pipes A and B are filling pipes, I am putting positive way. But pipe C is draining the water, I mean throwing the water outside. So in that case, it is doing a negative work, and that's the reason we are putting minus 1/20. Everything is clear to you, right? So here is where we have to be very careful, because pipe C is a negative work, okay, and this is a emptying pipe. That's the reason. So I will even just make a note of it so that it will be very easy for you to understand. Pipes A and pipes B, they are going to be filling pipes. So filling pipe. So they are positive workers. But pipe C here is an emptying pipe. So that's the reason we are making a minus. We are putting a minus 1/20. Fine, everything is okay. So therefore, all 3 pipes will do how much of the work in 1 hour? That we have to calculate. So in 1 hour, how much work is done? So by all 3, so this will be nothing but all 3 we have to take it up. So 1/12 plus 1/30 minus 1/20. This is what we have to do. So when we do so, what happens is this will be equal to, so let me take this space. So 12, 30 and 20. We can take the LCM here. So LCM of these 3 numbers is going to be, as usual, go for the larger number. So 30 here is the larger of all these numbers, right? So the largest one is 30 here. So go for 30 tables. 31s are 30. No, not divisible by the other numbers. 32s are is 60. Is it or not? And 60 fortunately is divisible by 12 and also 20. That's it. So 60 will take it to be the LCM. 60 is the LCM for these 3 numbers. So 60. So 12 and 60, this is going to be 5 times. So 1 5s are is 5. We have a plus. So plus 32s are the 60. So numerator 1 2s are is 2 minus, and last one 23s are is 60. So 1 3s are is 3. That's it. Okay, fine. So this will be equal to, so actually we get 5 plus 2 is 7. 7 minus 3 is 4. 4/60. This is what we will get. So 4/60, and this, even if we want to simplify, what happens? 4/60, we can simplify this, right? So this would give you 1/15. The reduced fraction is 1/15. So all 3 pipes can do 1/15th part of the work. What do you mean by that? It can fill 1/15. Why I am telling it can fill? It is very clear. We are getting the answer in terms of a positive value, positive fraction, right? So if in case we get a negative value, we can conclude that if all 3 join or all 3 work together, it will do a negative work. But here we get a positive value. So the thing is, overall in a net, if all three are working together, they can fill 1/15th of the tank. This is what it means. And obviously, what would be the time taken? Now with this we can very easily say, if in 1 hour all three pipes can fill 1/15th of the tank, then how much time it would take for them to fill the complete tank? I mean the tank, full tank. How much time would it take? Again the reciprocal 1/1/15th, or directly you can even conclude it. So 15 hours, it would take 15 hours for them to fill the full tank. I mean the complete work will be finished in 15 hours. That's going to be the answer. So answer for this question is going to be 15 hours. Yes, clear? So this is how you have to handle whenever you get a question which is based on this negative works. And as I told, this negative work will be mainly seen in problems which are based on this kind of pipes and cistern problems. Okay, yes. So have a view, and yes, I hope this problem what we have seen here is very clear to you, and also the concepts that we have seen here about pipes and cisterns, negative work, everything is very clear to you. And again have a view for a better understanding, and even after that you get any doubts or anything, sure, you are welcome to post it in the comment box, and if I see them, I will see that I'll rectify your doubts. And yes, again in our next video lesson we'll catch up with some other interesting topic. See you soon there. Thank you so much.